Picture this, a future where space travel is as routine as hopping on a plane, where rockets launch and land like clockwork, ready to take off again in hours instead of years. This isn't science fiction, it's the reality being built today, thanks to groundbreaking reusable spacecraft technologies. Over the next few minutes, we'll dive into 25 innovations that are reshaping how we explore the cosmos, making space travel more affordable, sustainable, and accessible than ever before. From reusable rocket boosters that slash launch costs to spaceplanes that glide back to Earth like airplanes, these technologies are unlocking a new era of exploration. But why does reusability matter so much? Imagine if every time you drove your car, you had to throw it away and buy a new one. Sounds absurd, right? That's exactly how traditional space travel has worked until now. By reusing spacecraft, we're not just saving billions of dollars, we're opening the door to a future where humanity can thrive beyond Earth. So, buckle up as we explore the technologies that are turning this vision into reality, one reusable innovation at a time. Now, let's take a closer look at the first game-changing innovation on our list, reusable rocket boosters. These engineering marvels, like the ones powering SpaceX's Falcon 9, have completely rewritten the rules of space travel. Traditionally, rockets were single-use, meaning they'd burn up or crash after a single launch, leaving behind a trail of astronomical costs. But reusable boosters flip the script. After launching their payloads into orbit, these boosters return to Earth, landing vertically with pinpoint precision. This ability to recover and reuse them has slashed launch costs by as much as 70%, making space missions far more economical. But it's not just about saving money. Reusable boosters also enable rapid turnaround times. For example, SpaceX has demonstrated that a Falcon 9 booster can be refurbished and relaunched in just a matter of weeks, compared to the years it once took to build a new rocket from scratch. This efficiency is a game-changer for industries like satellite deployment, space tourism, and even future missions to Mars. By reusing these boosters, we're not just cutting costs, we're accelerating the pace of space exploration itself. So, what does this mean for the future? Imagine a world where rockets are as reusable as airplanes, where launching into space becomes as routine as flying across the globe. That's the promise of reusable rocket boosters, and it's already happening today. As we move forward, this technology will continue to pave the way for more ambitious missions, bringing us closer to a future where space is truly within reach for everyone. Moving on to the next groundbreaking innovation, let's talk about reusable heat shields. These unsung heroes play a critical role in ensuring the safe return of spacecraft from orbit. When a spacecraft re-enters Earth's atmosphere, it faces extreme temperatures, often exceeding thousands of degrees Celsius. Without a reliable heat shield, the intense heat would destroy the vehicle in seconds. But reusable heat shields are designed to withstand this fiery ordeal, protecting both the spacecraft and its precious cargo or crew inside. What makes these heat shields truly remarkable is their ability to be used multiple times. Traditional heat shields were often single-use, requiring replacement after every mission. But advancements in materials like PICA-X, a high-performance thermal protection system developed by NASA and SpaceX, have changed the game. PICA-X is not only incredibly heat-resistant but also lightweight and durable, making it ideal for repeated use. This innovation has significantly reduced the cost of missions, as spacecraft no longer need entirely new heat shields for every launch. The benefits don't stop there. Reusable heat shields also enhance mission flexibility. For example, spacecraft equipped with these shields can be rapidly prepared for subsequent missions, cutting down on downtime and increasing the frequency of space travel. This is particularly important for missions involving crewed spacecraft, where safety and reliability are paramount. Looking ahead, reusable heat shields are set to play a pivotal role in future deep space missions. Whether it's returning from the Moon, Mars, or beyond, these shields will ensure that spacecraft can safely re-enter Earth's atmosphere time and time again. By making space travel more sustainable and cost-effective, reusable heat shields are helping to pave the way for a new era of exploration, one where the stars are no longer out of reach. Now, let's shift our focus to another game-changing innovation in reusable spacecraft technology: reusable spaceplanes. Unlike traditional capsules that splash down in the ocean or land in remote areas, spaceplanes are designed to glide back to Earth and land on runways, much like an airplane. This capability not only makes them reusable, but also significantly reduces the complexity and cost of recovery operations. One standout example of this technology is the Dream Chaser, a sleek, winged spacecraft developed by Sierra Space. The Dream Chaser is designed to carry both cargo and crew, offering a versatile solution for a variety of missions. After completing its mission in orbit, the Dream Chaser re-enters Earth's atmosphere and uses its aerodynamic design to glide smoothly to a runway landing. This approach eliminates the need for parachutes or ocean recovery teams, streamlining the process and enabling rapid turnaround for future missions. What makes reusable spaceplanes so revolutionary is their ability to combine the best features of aircraft and spacecraft. They can take off vertically like a rocket, operate in the vacuum of space, and then return to Earth with the precision and control of an airplane. This versatility opens up new possibilities for space travel, including more frequent and cost-effective missions to low Earth orbit. Another advantage of spaceplanes is their potential to enhance safety and comfort for crewed missions. Traditional capsules experience high gravitational forces and rough landings, which can be physically demanding for astronauts. In contrast, spaceplanes like the Dream Chaser offer a smoother re-entry and landing experience, reducing stress on both the crew and the spacecraft itself. Looking to the future, reusable spaceplanes could play a key role in expanding access to space. They are ideal for missions ranging from satellite deployment to space tourism, offering a reusable and efficient alternative to traditional spacecraft. By reducing the need for disposable capsules and simplifying recovery operations, spaceplanes are helping to make space travel more sustainable and accessible. As we continue to explore the possibilities of reusable spacecraft technologies, spaceplanes like the Dream Chaser remind us that innovation often lies at the intersection of different fields. By blending the principles of aviation and spaceflight, these vehicles are paving the way for a new era of exploration, one where the skies and the stars are no longer separate realms, but part of a seamless journey. Now, let's turn our attention to another groundbreaking innovation in reusable spacecraft technology: reusable satellite platforms. These platforms are revolutionizing the way we think about satellite missions by offering a sustainable and cost-effective solution for deploying and operating multiple payloads over their lifespan. Unlike traditional satellites, which are often designed for a single mission and then discarded, reusable satellite platforms are built to accommodate a variety of payloads, making them a game-changer for the space industry. One of the most exciting aspects of reusable satellite platforms is their ability to reduce space debris. With thousands of defunct satellites and fragments already cluttering Earth's orbit, the need for sustainable solutions has never been more urgent. By hosting multiple payloads on a single platform, these systems minimize the number of new satellites launched into orbit, thereby reducing the risk of collisions and the accumulation of space junk. This not only helps preserve the orbital environment, but also ensures safer conditions for future missions. Cost efficiency is another major advantage of reusable satellite platforms. Traditional satellite missions require significant investment in design, manufacturing, and launch for each new payload. In contrast, reusable platforms allow multiple missions to share the same infrastructure, spreading the costs over several payloads and lowering the overall expense. This approach makes space more accessible to a wider range of organizations, from government agencies to private companies and even academic institutions. A prime example of this technology is the development of modular satellite platforms, which can be easily reconfigured to support different types of payloads. These platforms are equipped with standardized interfaces, allowing new instruments or experiments to be added or replaced as needed. This flexibility not only extends the lifespan of the platform, but also enables it to adapt to evolving mission requirements, making it a versatile tool for scientific research, Earth observation, and telecommunications. Looking ahead, reusable satellite platforms have the potential to transform how we approach space missions. By reducing both costs and environmental impact, they are paving the way for more sustainable and scalable space exploration. Whether it's monitoring climate change, enhancing global communication networks, or advancing scientific discovery, these platforms are proving that reusability is not just a trend, it's the future of space technology. As we continue to explore the possibilities of reusable spacecraft, satellite platforms stand out as a shining example of how innovation can address some of the most pressing challenges in space travel. By combining sustainability, efficiency, and adaptability, they are helping to create a more accessible and responsible approach to exploring the final frontier. Now, let's shift our focus to the next frontier in reusable spacecraft technology, reusable lunar landers. These innovative systems are designed to not only transport humans and cargo to the moon, but also to do so repeatedly, making lunar exploration more sustainable and cost-effective. Unlike traditional landers that are used once and discarded, reusable lunar landers are built to withstand multiple missions, opening up new possibilities for long-term lunar presence and resource utilization. One of the most prominent examples of this technology is SpaceX's Starship, a fully reusable spacecraft intended to carry both crew and cargo to the Moon, Mars, and beyond. Starship's design allows it to land vertically on the lunar surface, refuel, and return to orbit or Earth, ready for its next mission. This capability is a game-changer for lunar exploration, as it significantly reduces the cost and complexity of sending missions to the Moon. Instead of building a new lander for every mission, reusable systems like Starship can be used over and over, making lunar exploration more accessible and sustainable. Reusable lunar landers also play a crucial role in supporting the utilization of lunar resources. The Moon is rich in materials like water ice, which can be converted into fuel, oxygen, and even drinking water for future missions. By enabling repeated trips to the Moon, reusable landers make it feasible to establish infrastructure for mining and processing these resources. This not only reduces the need to transport supplies from Earth, but also lays the groundwork for a self-sustaining lunar economy, which could support deeper space exploration efforts. Another key advantage of reusable lunar landers is their ability to support scientific research and exploration over extended periods. With the ability to return to the Moon multiple times, these landers can deliver new instruments, collect samples, and even transport astronauts for extended stays. This opens up opportunities for more comprehensive studies of the lunar environment, from its geology to its potential for supporting human life. By enabling continuous access to the Moon, reusable landers are helping to unlock the secrets of our closest celestial neighbor. As we look to the future, reusable lunar landers are set to play a pivotal role in humanity's return to the Moon and beyond. By combining reusability with advanced technology, they are making lunar exploration more sustainable, affordable, and impactful. Whether it's establishing a permanent lunar base, mining resources, or conducting groundbreaking research, these landers are proving that the Moon is not just a destination, it's a stepping stone to the stars. With reusable lunar landers leading the way, the dream of sustainable lunar exploration is becoming a reality. As we continue to push the boundaries of space travel, these systems remind us that innovation and sustainability go hand in hand, paving the way for a future where the moon is not just a place to visit, but a place to thrive. Now, let's turn our attention to another groundbreaking innovation in reusable spacecraft technology: reusable orbital transfer vehicles. These vehicles are revolutionizing how we move payloads between different orbits, offering a more efficient and sustainable alternative to traditional methods. Unlike disposable upper stages, which are used once and then discarded, reusable orbital transfer vehicles are designed to operate multiple times, significantly reducing waste and lowering mission costs. Reusable orbital transfer vehicles act as space taxis, shuttling satellites, cargo, or even crew modules from one orbit to another. For example, a satellite launched into low Earth orbit might need to reach a higher geostationary orbit to fulfill its mission. Instead of relying on a single-use upper stage to make this transfer, a reusable vehicle can perform the task repeatedly, ensuring that the process is both cost-effective and environmentally friendly. This capability is particularly valuable for missions requiring precise orbital adjustments or those involving multiple payloads. One of the key advantages of these vehicles is their ability to extend the lifespan of existing satellites. By providing a means to reposition aging satellites or repair them in orbit, reusable transfer vehicles help maximize the return on investment for space missions. This not only reduces the need for launching new satellites, but also helps address the growing issue of space debris, as fewer discarded components are left in orbit. The development of reusable orbital transfer vehicles is also paving the way for more ambitious space missions. For instance, they could play a critical role in supporting lunar or Martian exploration by transporting supplies and equipment between Earth's orbit and destinations further out in the solar system. By enabling efficient movement of resources, these vehicles are helping to create a more interconnected and sustainable space infrastructure. As we look ahead, reusable orbital transfer vehicles are set to become an essential component of space travel. Their ability to reduce costs, minimize waste, and enhance mission flexibility makes them a cornerstone of the next era of space exploration. By reimagining how we move through space, these vehicles are not just transforming orbital logistics, they're opening up new possibilities for humanity's journey among the stars. With reusable orbital transfer vehicles leading the charge, the future of space travel is becoming more efficient, sustainable, and interconnected. As we continue to innovate, these systems remind us that the sky is not the limit, it's just the beginning. Now, let's shift our focus to another fascinating innovation in reusable spacecraft technology: reusable space habitats. These habitats are designed to support long-term human presence in space, whether in orbit around Earth or on other celestial bodies like the Moon or Mars. Unlike traditional space stations, which are often single-use or limited in their lifespan, reusable space habitats are built to be durable, adaptable, and capable of supporting multiple missions over many years. One of the most prominent examples of this concept is NASA's Lunar Gateway, a planned space station that will orbit the Moon. The gateway is designed to serve as a reusable hub for lunar exploration, providing a place for astronauts to live, work, and conduct scientific research. It will also act as a staging point for missions to the lunar surface and beyond, making it a critical component of sustainable space exploration. By reusing the gateway for multiple missions, NASA aims to reduce costs and maximize the scientific and exploratory potential of each mission. Reusable space habitats are not just about providing shelter, they're about creating a sustainable living environment for humans in the harsh conditions of space. These habitats are equipped with advanced life support systems that recycle air, water, and waste, ensuring that astronauts can survive for extended periods without constant resupply from Earth. This self-sufficiency is crucial for long-duration missions, such as those to Mars, where resupply missions would be impractical due to the vast distances involved. Another key advantage of reusable space habitats is their modular design. This allows them to be expanded or reconfigured as needed, accommodating new technologies or additional crew members. For example, a habitat initially designed for lunar exploration could later be adapted for use on Mars, making it a versatile asset for future missions. This flexibility not only reduces the need to build entirely new habitats for each mission, but also ensures that space agencies can adapt to changing goals and priorities. The development of reusable space habitats is also paving the way for commercial space ventures. Companies are exploring the possibility of building private space stations that could host scientific experiments, manufacturing processes, or even space tourism. By making space habitats reusable, these ventures become more economically viable, opening up new opportunities for innovation and collaboration in the space industry. As we look to the future, reusable space habitats will play a vital role in enabling humanity's expansion into the solar system. They provide the infrastructure needed for long-term exploration and settlement, turning what was once science fiction into a tangible reality. By creating sustainable living spaces in orbit and beyond, these habitats are helping to ensure that humanity's journey into space is not just a series of short visits but a lasting presence among the stars. With reusable space habitats, the dream of living and working in space is becoming more achievable than ever. They represent a critical step forward in our quest to explore new worlds and expand the boundaries of human knowledge. As we continue to innovate, these habitats remind us that the challenges of space are not insurmountable. They are opportunities to build a future where humanity thrives beyond Earth. Now, let's turn our attention to another groundbreaking innovation in reusable spacecraft technology: reusable cargo ships. These vessels are revolutionizing how we transport supplies and equipment to space, making missions more efficient and cost-effective. One of the most well-known examples is SpaceX's Dragon spacecraft, which has become a cornerstone of resupply missions to the International Space Station. Reusable cargo ships like Dragon are designed to carry essential supplies, scientific experiments, and equipment to the International Space Station, ensuring that astronauts have everything they need to live and work in orbit. What sets these ships apart is their ability to return to Earth intact, allowing them to be refurbished and reused for multiple missions. This reusability drastically reduces the cost of space travel, as it eliminates the need to build a new spacecraft for every launch. Instead of being discarded after a single use, these cargo ships can be reloaded and sent back into space, making them a sustainable solution for ongoing missions. The Dragon spacecraft, for instance, has successfully completed numerous resupply missions to the International Space Station, delivering thousands of pounds of cargo and returning with valuable scientific samples and equipment. Its ability to safely re-enter Earth's atmosphere and land with precision has made it a reliable workhorse for NASA and other space agencies, but the potential of reusable cargo ships extends far beyond low Earth orbit. As we look toward deep space missions, these vessels could play a critical role in supporting human exploration of the Moon, Mars, and beyond. Imagine a future where reusable cargo ships are used to transport supplies to lunar bases or Martian colonies. These ships could deliver everything from food and water to construction materials and advanced scientific instruments, enabling long-term human presence on other worlds. By reusing these vessels, we can significantly reduce the logistical challenges and costs associated with deep space exploration, making it more feasible to establish sustainable outposts on distant planets. Another exciting aspect of reusable cargo ships is their potential to support commercial space ventures. Companies are already exploring the possibility of using these vessels to transport goods for space-based manufacturing or even space tourism. By making cargo transport more affordable and efficient, reusable ships open up new opportunities for innovation and collaboration in the space industry. They could also play a key role in building the infrastructure needed for large-scale projects, such as space-based solar power stations or asteroid mining operations. The development of reusable cargo ships is a testament to the ingenuity and determination of the space industry. These vessels are not just about delivering supplies, they're about creating a sustainable framework for space exploration. By reducing waste and maximizing efficiency, reusable cargo ships are helping to pave the way for humanity's future in space. They remind us that the challenges of space travel are not just technical, they're also about finding smarter, more sustainable ways to explore the cosmos. As we continue to push the boundaries of what's possible, reusable cargo ships will remain a vital part of our journey into the stars. They represent a practical solution to one of the biggest hurdles in space exploration, the need for reliable, cost-effective transportation. With each mission, these ships bring us one step closer to a future where humanity thrives not just on Earth, but among the stars. Now, let's shift our focus to another fascinating innovation in reusable spacecraft technology, reusable space tugs. These versatile vehicles are changing the game when it comes to managing satellites and cleaning up space debris, offering a sustainable solution to some of the most pressing challenges in orbit. Reusable space tugs are designed to perform a variety of tasks, from repositioning satellites to removing defunct spacecraft and debris from Earth's orbit. Unlike traditional systems that are often discarded after a single use, these tugs can be deployed multiple times, making them a cost-effective and environmentally friendly option. By extending the lifespan of existing satellites and reducing the amount of space debris, reusable space tugs are helping to ensure the long-term sustainability of space activities. One of the key advantages of reusable space tugs is their ability to rescue satellites that have drifted out of their intended orbits. Over time, satellites can experience orbital decay or malfunctions that render them less effective. Space tugs can intercept these satellites, adjust their trajectories, and place them back into their correct orbits, restoring their functionality and maximizing their operational lifespan. This capability is particularly valuable for expensive communication or Earth observation satellites, where even a small adjustment can save millions of dollars and years of service. But the role of reusable space tugs doesn't stop there. They are also being developed to tackle the growing problem of space debris. With thousands of defunct satellites, spent rocket stages, and other fragments cluttering Earth's orbit, the risk of collisions is increasing. These collisions can create even more debris, leading to a dangerous cycle known as the Kessler syndrome. Reusable space tugs offer a proactive solution by capturing and removing this debris, either by deorbiting it to burn up in Earth's atmosphere or by relocating it to a safer orbit. This not only reduces the risk of collisions, but also helps to preserve the usability of valuable orbital real estate. The development of reusable space tugs is also opening up new possibilities for satellite servicing and maintenance. Imagine a future where these tugs can dock with aging satellites to refuel them, repair damaged components, or even upgrade their technology. This would dramatically extend the lifespan of satellites, reducing the need for costly replacements and minimizing the environmental impact of space activities. Companies and space agencies are already exploring these concepts, with prototypes and missions in the works to demonstrate the feasibility of such operations. As we look to the future, reusable space tugs could play a critical role in supporting large-scale space infrastructure projects. For example, they could assist in assembling and maintaining space-based solar power stations, orbital habitats, or even interplanetary transport hubs. By providing reliable and reusable transportation and maintenance services, these tugs could help to build the foundation for a thriving space economy. The rise of reusable space tugs is a testament to the ingenuity of the space industry. These vehicles are not just about solving immediate problems, they're about creating a sustainable framework for the future of space exploration. By extending the lifespan of satellites, cleaning up debris, and enabling new possibilities for satellite servicing, reusable space tugs are helping to ensure that space remains a viable and accessible frontier for generations to come. They remind us that innovation isn't just about reaching new heights, it's also about taking care of the space we already have. Now, let's turn our attention to another groundbreaking innovation in reusable spacecraft technology: reusable spacesuits. These advanced suits are revolutionizing how astronauts operate in space, offering a sustainable and cost-effective solution for long-duration missions. Unlike traditional spacesuits, which are often designed for single-use or limited missions, reusable spacesuits are built to withstand multiple missions, with modular components that can be easily repaired or replaced as needed. The concept of reusable spacesuits is rooted in the need for durability and flexibility. Space is an unforgiving environment, and traditional suits can degrade over time due to exposure to extreme temperatures, micrometeoroids, and radiation. Reusable suits address these challenges by incorporating materials and designs that are more resilient and adaptable. For example, modular components like gloves, boots, and life support systems can be swapped out if they become damaged or outdated, extending the overall lifespan of the suit. This not only reduces waste but also ensures that astronauts have access to the latest technology without requiring entirely new suits for each mission. One of the most exciting aspects of reusable spacesuits is their potential to support long-term missions, such as those to the Moon, Mars, or beyond. On extended missions, the ability to repair or upgrade a spacesuit is crucial. Imagine an astronaut on Mars needing to replace a worn-out glove or upgrade their life support system. With reusable suits, these tasks become manageable, ensuring that astronauts can continue their work safely and efficiently. This modular approach also allows for customization, enabling suits to be tailored to the specific needs of different missions or individual astronauts. Another key advantage of reusable spacesuits is their cost-effectiveness. Developing a single spacesuit is an expensive and time-consuming process, often costing millions of dollars. By designing suits that can be used multiple times, space agencies and private companies can significantly reduce costs. This is especially important as space exploration becomes more accessible, with more missions planned by a growing number of organizations. Reusable suits make it possible to allocate resources more efficiently, ensuring that more funding can be directed toward other critical aspects of space exploration. The development of reusable space suits also aligns with the broader goal of sustainability in space. Just as reusable rockets and spacecraft are reducing the environmental impact of space travel, reusable suits are helping to minimize waste and resource consumption. This is particularly important as humanity looks to establish a long-term presence in space. By creating systems that are designed for reuse and repair, we are laying the foundation for a more sustainable approach to space exploration. Looking ahead, reusable spacesuits could play a vital role in supporting large-scale space habitats and colonies. As humans venture further into the solar system, the need for reliable and adaptable spacesuits will only grow. These suits could be used not only for exploration but also for construction, maintenance, and even emergency repairs. By combining durability, modularity, and cost-effectiveness, reusable spacesuits are poised to become an essential tool for the next generation of space explorers. The innovation behind reusable spacesuits is a testament to the ingenuity of the space industry. These suits are not just about protecting astronauts, they're about enabling the future of space exploration. By making space suits more durable, adaptable, and sustainable, we are taking a significant step toward ensuring that space remains a viable and accessible frontier for generations to come. As we continue to push the boundaries of what's possible, reusable spacesuits remind us that even the smallest innovations can have a profound impact on the future of humanity in space. Now, let's shift our focus to another game-changing innovation in reusable spacecraft technology: reusable propellant depots. These orbital refueling stations are set to revolutionize how we approach long-duration space missions, offering a practical solution to one of the biggest challenges in space travel: fuel management. Imagine a gas station in space where spacecraft can dock, refuel, and continue their journey without the need to carry all their fuel from the start. This concept is not just futuristic, it's a critical step toward making space exploration more efficient and sustainable. The idea behind reusable propellant depots is simple yet transformative. Instead of launching massive rockets with all the fuel needed for a mission, spacecraft can carry just enough to reach orbit where they can refuel at a depot. This approach drastically reduces the size and weight of the spacecraft, making launches more cost-effective and less resource-intensive. By storing fuel in orbit, these depots act as a strategic reserve, enabling missions to travel farther and last longer without the need for larger, more expensive rockets. One of the most exciting applications of reusable propellant depots is their potential to support missions to the Moon, Mars, and beyond. For example, a spacecraft heading to Mars could stop at a depot in Earth's orbit to top off its fuel tanks before embarking on the long journey. This not only extends the range of the spacecraft but also allows for more flexibility in mission planning. If a spacecraft runs low on fuel during its mission, it could potentially return to a depot for a refill, ensuring that it can complete its objectives without being limited by fuel constraints. The development of reusable propellant depots also opens up new possibilities for in-space infrastructure. These depots could be strategically placed in key orbits, creating a network of refueling stations that support a wide range of missions. From satellite servicing to deep space exploration, the ability to refuel in orbit could fundamentally change how we design and execute space missions. This infrastructure would also support the growing number of private and commercial space ventures, making space more accessible to a broader range of organizations. Another significant advantage of reusable propellant depots is their potential to reduce space debris. By enabling spacecraft to refuel and continue their missions, these depots could help extend the operational lifespan of satellites and other assets, reducing the need for replacements and minimizing the accumulation of debris in orbit. This aligns with the broader goal of creating a more sustainable space environment, where resources are used efficiently and waste is minimized. The technology behind reusable propellant depots is still in its early stages, but the potential is immense. Advances in fuel storage, transfer systems, and autonomous docking technologies are making this concept increasingly feasible. As these technologies mature, we could see the first operational depots within the next decade, paving the way for a new era of space exploration. Reusable propellant depots represent a bold step forward in our quest to explore the cosmos. By addressing the challenge of fuel management, these depots are unlocking new possibilities for longer, more ambitious missions. They are not just a tool for exploration, they are a cornerstone of a sustainable and accessible future in space. As we continue to push the boundaries of what's possible, reusable propellant depots remind us that innovation is the key to overcoming the challenges of space travel and opening up the final frontier for generations to come. Now, let's take a closer look at another groundbreaking innovation that's reshaping the future of space exploration: reusable space-based manufacturing platforms. Imagine a world where instead of launching every component of a spacecraft from Earth, we could build and assemble them directly in orbit. This concept isn't just science fiction. It's a practical solution that could revolutionize how we approach space missions, making them more efficient, cost-effective, and sustainable. Reusable space-based manufacturing platforms aim to address one of the biggest challenges in space travel: the sheer cost and complexity of launching heavy payloads from Earth. Every kilogram of material sent into space requires a significant amount of fuel and resources, driving up mission costs. By shifting manufacturing to orbit, we can drastically reduce the need to launch large, pre-built components, instead sending raw materials or smaller modules that can be assembled in space. This approach not only cuts costs but also opens up new possibilities for designing spacecraft and structures that are optimized for the unique conditions of space. One of the most exciting applications of this technology is the ability to create large-scale structures such as space stations or solar arrays that would be impossible to launch from Earth in one piece. For example, imagine constructing a massive solar power station in orbit with panels that are manufactured and assembled on site. These platforms could also produce spare parts for satellites or spacecraft, extending their operational lifespan and reducing the need for costly replacements. This capability would be a game changer for long-duration missions where access to spare parts is often limited. Another key advantage of reusable space-based manufacturing platforms is their potential to support sustainable space exploration. By recycling materials and using resources found in space, such as metals from asteroids or lunar regolith, these platforms could reduce our reliance on Earth's resources. This not only makes missions more self-sufficient, but also minimizes the environmental impact of space exploration. Over time, this could lead to the development of a self-sustaining space economy, where materials are harvested, processed, and used in orbit without the need for constant resupply from Earth. The technology behind these platforms is still evolving, but significant progress has already been made. Advances in robotics, three-dimensional printing, and autonomous systems are making it increasingly feasible to manufacture complex components in the microgravity environment of space. Companies and space agencies are already experimenting with in-orbit manufacturing, testing everything from small satellite components to advanced materials. As these technologies mature, we could see the first fully operational manufacturing platforms within the next decade, paving the way for a new era of space exploration. Reusable space-based manufacturing platforms represent a bold leap forward in our ability to explore and utilize space. By enabling in-orbit construction and production, these platforms are not only reducing costs but also unlocking new possibilities for innovation and sustainability. They remind us that the future of space exploration isn't just about reaching new destinations. It's about building the infrastructure that will allow us to thrive in the cosmos. As we continue to push the boundaries of what's possible, these platforms will play a crucial role in shaping a future where space is not just a frontier to explore, but a place to live and work. Now, shifting our gaze to the stars, let's explore another transformative technology, reusable space telescopes. These remarkable instruments are not just tools for observing the cosmos. They represent a new era of sustainability and innovation in space exploration. Unlike traditional telescopes, which are often launched, used, and eventually abandoned, reusable space telescopes are designed to be serviced, upgraded, and maintained in orbit, ensuring they remain at the cutting edge of scientific discovery for decades. One of the most significant advantages of reusable space telescopes is their ability to adapt to new technologies and scientific needs. Imagine a telescope that can receive new instruments or software updates while still in space, much like how we update our smartphones here on Earth. This flexibility allows scientists to enhance the telescope's capabilities without the need for costly and time-consuming replacement missions. For example, a reusable telescope could be upgraded with more advanced cameras or sensors, enabling it to capture higher resolution images or detect previously unseen phenomena in the universe. The concept of servicing telescopes in orbit isn't entirely new. The Hubble Space Telescope, launched in 1990, has been serviced multiple times by astronauts, allowing it to continue operating far beyond its original expected lifespan. These servicing missions have not only extended Hubble's life, but also significantly improved its performance, demonstrating the immense value of reusability in space-based observatories. However, reusable space telescopes take this idea a step further by incorporating modular designs and robotic servicing capabilities. reducing the need for human intervention and making the process more efficient. Another exciting aspect of reusable space telescopes is their potential to reduce space debris. Traditional telescopes, once decommissioned, often remain in orbit as non-functional relics, contributing to the growing problem of space clutter. In contrast, reusable telescopes can be repaired, upgraded, or even deorbited in a controlled manner, minimizing their impact on the space environment. This approach aligns with the broader goal of creating a sustainable space ecosystem, where resources are used responsibly and waste is minimized. The development of reusable space telescopes also opens up new possibilities for international collaboration. By creating telescopes that can be shared and upgraded by multiple space agencies or private companies, we can pool resources and expertise to achieve more ambitious scientific goals. This collaborative model could lead to the creation of next-generation observatories capable of answering some of the most profound questions about our universe, from the nature of dark matter to the search for habitable exoplanets. As we look to the future, reusable space telescopes promise to revolutionize our understanding of the cosmos. By combining cutting-edge technology with a commitment to sustainability, these instruments will not only extend the lifespan of space-based observatories, but also ensure that they remain at the forefront of scientific discovery. They remind us that the pursuit of knowledge is not a one-time endeavor but an ongoing journey, one that requires innovation, adaptability, and a vision for the long term. With reusable space telescopes, the stars are no longer just a destination. They are a canvas for endless exploration and discovery. Now, let's turn our attention to a groundbreaking innovation that could redefine how we harness resources beyond Earth: reusable space mining equipment. As humanity sets its sights on deeper space exploration, the ability to extract and utilize resources from celestial bodies like asteroids or the Moon becomes not just a possibility but a necessity. Reusable mining equipment is at the heart of this vision, offering a sustainable way to fuel our journeys and build infrastructure in space. Imagine a future where mining robots, designed for multiple missions, land on an asteroid, extract valuable metals like platinum or rare earth elements, and return to a space station to process the materials. These robots could then be refueled, repaired, and sent out again to mine another location. This approach eliminates the need to constantly launch new equipment from Earth, drastically reducing costs and environmental impact. It's a game changer for space exploration, enabling us to create a self-sustaining ecosystem in space. One of the most exciting aspects of reusable mining equipment is its potential to support long-term missions. For example, water ice mined from the Moon could be converted into hydrogen and oxygen, providing both fuel for spacecraft and breathable air for astronauts. This concept, known as in situ resource utilization, could make missions to Mars and beyond far more feasible by reducing the amount of supplies we need to carry from Earth. Reusable mining systems are the key to unlocking this capability, ensuring that we can harvest and process resources efficiently wherever we go. The development of such equipment is already underway. Companies and space agencies are testing robotic systems capable of drilling, excavating, and transporting materials in low-gravity environments. These systems are designed to withstand the harsh conditions of space, from extreme temperatures to abrasive lunar dust, while being modular enough to be repaired or upgraded as needed. By making mining equipment reusable, we're not just solving a technical challenge, we're paving the way for a sustainable future in space. Another critical benefit of reusable mining equipment is its role in reducing space debris. Traditional one-time use systems, once their mission is complete, often become part of the growing clutter in Earth's orbit. In contrast, reusable systems can be maintained, repurposed, or even returned to Earth, minimizing their impact on the space environment. This aligns with the broader goal of responsible space exploration, where every piece of technology is designed with sustainability in mind. As we look ahead, reusable space mining equipment represents more than just a technological breakthrough. It's a cornerstone of humanity's future in space. By enabling us to tap into the vast resources of our solar system, these systems will support everything from scientific research to the construction of lunar bases and interplanetary colonies. They remind us that the next frontier isn't just about exploration, it's about building a sustainable presence beyond our planet. With reusable mining equipment, the stars are no longer out of reach, they're a source of endless opportunity. Now, shifting our focus to the skies above, let's explore how reusable components are revolutionizing the concept of space-based solar power stations. Imagine a future where massive solar arrays orbit Earth, capturing sunlight 24 hours a day, free from the limitations of weather or nighttime. These stations could beam clean, renewable energy back to our planet, providing a virtually limitless power source. But what makes this vision truly achievable is the integration of reusable technologies. Traditional solar power stations in space would require frequent maintenance and upgrades, which, without reusability, would mean launching new components every time, a costly and inefficient process. However, with reusable systems, we can design solar arrays that are modular and repairable. Picture robotic arms or autonomous drones that can replace damaged panels, upgrade outdated technology, or even reposition the arrays to maximize sunlight exposure. These reusable components ensure that the stations remain operational for decades, drastically reducing the need for constant launches from Earth. One of the most exciting aspects of reusable space-based solar power stations is their potential to address Earth's energy crisis. Unlike ground-based solar farms, which are limited by geography and weather, space-based stations can generate power continuously. By using reusable components, we can scale up these systems over time, creating a network of solar arrays that could supply clean energy to entire continents. This isn't just a step toward sustainability, it's a leap toward energy independence. Another key advantage is the environmental impact. Traditional energy sources like fossil fuels contribute to pollution and climate change, but space-based solar power offers a clean alternative. And with reusable components, the environmental footprint of maintaining these stations is minimized. Instead of discarding old or broken parts, we can repair, refurbish, and reuse them, aligning with the principles of a circular economy. This approach not only reduces waste but also makes the entire system more cost-effective in the long run. The development of reusable space-based solar power stations is already gaining momentum. Companies and space agencies are exploring innovative designs, such as lightweight, foldable solar panels that can be easily transported and deployed in orbit. These panels are built to withstand the harsh conditions of space, from extreme temperatures to micrometeoroid impacts, while being designed for easy repair or replacement. By making these systems reusable, we're not just solving an engineering challenge, we're creating a sustainable energy solution for the future. As we look to the stars, reusable space-based solar power stations remind us that the solutions to Earth's challenges might lie beyond our atmosphere. By harnessing the power of the sun and combining it with reusable technologies, we can create a cleaner, brighter future for generations to come. This isn't just about energy, it's about reimagining what's possible when we think beyond the limits of our planet. Now, let's take a thrilling leap into the world of space tourism, where reusable vehicles are turning the dream of traveling beyond Earth into a reality for more people than ever before. Imagine boarding a spacecraft not as an astronaut but as a tourist, ready to experience the awe-inspiring view of our planet from the edge of space. This is no longer science fiction thanks to reusable space tourism vehicles like Virgin Galactic's Spaceship Two. The cosmos is becoming a destination within reach. Reusable space tourism vehicles are designed to make space travel not just possible but practical. Unlike traditional spacecraft that are used once and discarded, these vehicles are built to fly multiple missions, significantly reducing the cost per flight. Spaceship Two, for example, is a suborbital spaceplane that can carry passengers to the edge of space and return to Earth, landing on a runway like an airplane. This reusability is key to making space tourism affordable, as the high costs of building and launching new vehicles for every trip are eliminated. The impact of reusable space tourism vehicles goes beyond just lowering costs. They're also making space travel safer and more reliable. By flying the same vehicle multiple times, engineers can gather valuable data on its performance, identify potential issues, and make improvements. This iterative process ensures that each flight is safer than the last, building confidence in the technology and the experience. For passengers, this means not only a lower price tag, but also peace of mind as they prepare for their journey. Another exciting aspect of reusable space tourism vehicles is their potential to inspire a new generation of space enthusiasts. By opening up space travel to private citizens, these vehicles are democratizing access to the cosmos. Imagine the stories and photos shared by those who have seen Earth from above, sparking curiosity and wonder in others. This isn't just about a joyride. It's about fostering a deeper connection to space and encouraging more people to support and participate in space exploration. The development of reusable space tourism vehicles is also driving innovation in other areas of space travel. The technologies and lessons learned from these vehicles are being applied to larger, more ambitious projects such as orbital hotels and even interplanetary travel. By proving that reusable systems can work for tourism, we're paving the way for even more groundbreaking advancements in the future. As we look ahead, reusable space tourism vehicles are set to transform not just how we travel, but how we think about space. They're making the cosmos accessible to more people, inspiring new ideas, and proving that the final frontier isn't just for astronauts, it's for all of us. With each flight, we're taking one step closer to a future where space travel is as common as air travel, and the stars are no longer out of reach. Now, let's shift our gaze beyond Earth's orbit and into the vast expanse of interplanetary space, where reusable transport systems are redefining what's possible for humanity's future. Imagine a spacecraft capable of not just reaching Mars, but doing so repeatedly, carrying both humans and cargo to establish a sustainable presence on the red planet. This is the promise of reusable interplanetary transport systems, and leading the charge is SpaceX's Starship, a groundbreaking vehicle designed to make interplanetary travel a reality. Reusable interplanetary transport systems are a game changer for space exploration. Unlike traditional spacecraft that are used once and discarded, these systems are built to endure multiple missions, drastically reducing the cost and complexity of traveling to distant worlds. Starship, for instance, is designed to carry up to 100 people or a significant amount of cargo, and its fully reusable design means it can return to Earth, refuel, and launch again. This reusability is critical for making long-term missions to Mars and beyond economically feasible. The development of Starship and similar systems is driven by the goal of creating a self-sustaining human presence on Mars. By transporting both people and essential supplies, these vehicles aim to support the construction of habitats, the extraction of local resources, and even the establishment of industries on other planets. This isn't just about exploration, it's about colonization, ensuring that humanity can thrive beyond Earth. One of the most exciting aspects of reusable interplanetary transport systems is their potential to revolutionize how we think about space travel. Instead of one-way missions, these systems enable round-trip journeys, making it possible for astronauts and eventually civilians to travel to Mars and return home. This opens up possibilities for scientific research, economic opportunities, and even tourism on other planets. Imagine a future where traveling to Mars is as routine as flying across continents. The challenges of developing these systems are immense. from ensuring the spacecraft can withstand the harsh conditions of interplanetary travel to creating the infrastructure needed for refueling and maintenance. However, the progress being made is remarkable. Starship, for example, has already undergone several test flights, with each iteration bringing us closer to a fully operational system. These tests provide invaluable data, helping engineers refine the design and improve safety and reliability. Reusable interplanetary transport systems also have implications beyond Mars. They could enable missions to the Moon, asteroids, and even the outer planets, expanding our reach and understanding of the solar system. By proving that reusable systems can work for interplanetary travel, we're laying the foundation for a future where humanity is no longer confined to Earth. As we look to the stars, reusable interplanetary transport systems like Starship are leading the way, turning science fiction into science fact. They're not just vehicles, they're the key to unlocking a new era of exploration, discovery, and possibility. With each test flight and milestone, we're one step closer to a future where the cosmos is within our grasp, and the dream of becoming an interplanetary species is no longer a dream but a destiny. Now, let's turn our attention to a pressing issue closer to home, Earth's orbit, where reusable space debris collectors are playing a crucial role in safeguarding the future of space exploration. Picture this: thousands of defunct satellites, spent rocket stages, and fragments of old spacecraft cluttering our planet's orbit, posing a significant threat to active missions and the International Space Station. This growing problem, known as space debris, is a challenge that reusable debris collectors are uniquely equipped to tackle. Reusable space debris collectors are designed to address this issue head-on. Unlike single-use solutions, these innovative systems can capture and remove multiple pieces of debris over their operational lifespan, making them a sustainable and cost-effective approach to cleaning up Earth's orbit. By reusing the same collector for multiple missions, we can significantly reduce the cost and complexity of debris removal, ensuring that space remains accessible for future generations. The importance of these collectors cannot be overstated. Space debris travels at incredibly high speeds, and even a small piece can cause catastrophic damage to satellites or spacecraft. This not only endangers current missions but also threatens the long-term sustainability of space activities. Reusable debris collectors help mitigate this risk by actively removing hazardous objects from orbit, creating a safer environment for both human and robotic missions. One of the most promising aspects of reusable debris collectors is their versatility. Some designs use robotic arms or nets to capture debris, while others employ advanced technologies like lasers or tethers to deorbit objects safely. Once collected, the debris can either be brought back to Earth for disposal or guided to burn up in the atmosphere. This flexibility allows these systems to adapt to different types of debris and mission requirements, making them a valuable tool in the fight against space clutter. The development of reusable debris collectors is also driving innovation in space sustainability. Companies and space agencies are exploring new materials and technologies to improve the efficiency and durability of these systems. For example, some collectors are being designed with self-repairing components or advanced navigation systems to enhance their performance in the challenging environment of space. These advancements not only improve debris removal but also pave the way for other reusable technologies in orbit. Beyond their immediate benefits, reusable debris collectors have broader implications for the future of space exploration. By keeping Earth's orbit clean, they ensure that critical infrastructure like communication satellites, weather monitoring systems, and scientific instruments can operate safely and reliably. This, in turn, supports global connectivity, disaster response, and our understanding of the planet and the universe. As we continue to expand our presence in space, the need for sustainable solutions like reusable debris collectors will only grow. These systems represent a proactive approach to preserving the space environment, ensuring that it remains a resource for exploration, innovation, and discovery. With each successful mission, we're not just cleaning up debris, we're building a foundation for a safer, more sustainable future in space. Next, we'll explore how reusable space-based communication satellites are revolutionizing global connectivity, making space technology more accessible than ever before. Now, let's shift our focus to the skies above, where reusable space-based communication satellites are transforming how we connect across the globe. Imagine a world where reliable internet and communication services are accessible to even the most remote corners of the planet. This vision is becoming a reality thanks to the development of reusable communication satellites, which are not only cutting costs but also revolutionizing global connectivity. Traditional communication satellites are often single-use, meaning they are launched, serve their purpose, and then become space debris once their mission ends. Reusable communication satellites, on the other hand, are designed to be refurbished, upgraded, and redeployed for multiple missions. This approach drastically reduces the cost of maintaining and expanding global communication networks, making it more affordable to bring high-speed internet and other services to underserved areas. One of the most significant advantages of reusable communication satellites is their ability to adapt to changing technological needs. As demand for faster and more reliable communication grows, these satellites can be upgraded with new hardware or software while still in orbit. This flexibility ensures that they remain relevant and effective over time, providing continuous service without the need for frequent replacements. For example, a reusable satellite could be equipped with advanced antennas or processing capabilities to meet the growing demands of data transmission, all without requiring a costly new launch. The cost savings from reusability also have a ripple effect on global connectivity. By lowering the financial barriers to deploying and maintaining communication satellites, more organizations, from governments to private companies, can invest in expanding access to communication services. This is particularly impactful for developing regions, where the high cost of traditional satellite technology has historically limited access to reliable internet and communication infrastructure. Reusable satellites make it possible to bridge this digital divide, empowering communities with access to education, healthcare, and economic opportunities. Another key benefit of reusable communication satellites is their contribution to sustainability. By extending the lifespan of each satellite and reducing the need for new launches, these systems help minimize space debris and the environmental impact of rocket launches. This aligns with broader efforts to make space exploration and technology more sustainable, ensuring that the benefits of connectivity do not come at the expense of our planet or the space environment. The potential of reusable communication satellites extends beyond Earth as well. As we look toward future missions to the Moon, Mars, and beyond, these satellites could play a crucial role in maintaining communication networks across vast distances. Imagine a fleet of reusable satellites providing seamless communication between Earth, lunar bases, and interplanetary spacecraft, enabling real-time collaboration and data sharing across the solar system. In essence, reusable communication satellites are more than just a technological advancement. They are a gateway to a more connected and inclusive world. By reducing costs, improving adaptability, and promoting sustainability, these systems are paving the way for a future where everyone, no matter where they are, can stay connected. Next, we'll dive into the exciting potential of reusable space-based research platforms, where scientific discovery knows no bounds. Now, let's turn our attention to the fascinating world of reusable space-based research platforms, where the boundaries of scientific discovery are being pushed further than ever before. Imagine a laboratory floating in orbit where experiments can be conducted in the unique environment of microgravity, free from the constraints of Earth's gravity. These reusable platforms are not just a futuristic concept, they are already transforming how we conduct research in space. opening up endless possibilities for innovation and exploration. One of the most exciting aspects of reusable space-based research platforms is their ability to host a wide range of scientific experiments over multiple missions. Unlike traditional research modules that are often discarded after a single use, these platforms can be refurbished, upgraded, and reused for new experiments. This reusability significantly reduces the cost of conducting research in space, making it more accessible to scientists, universities, and private companies around the world. Whether it's studying the effects of microgravity on biological systems, developing new materials, or testing advanced technologies, these platforms provide a sustainable and cost-effective way to conduct groundbreaking research. The microgravity environment of space offers unique conditions that are impossible to replicate on Earth. For example, scientists can study how cells behave without the influence of gravity, leading to new insights into human health and disease. Similarly, materials science experiments in microgravity can result in the creation of stronger, lighter, and more efficient materials that could revolutionize industries like aerospace, construction, and electronics. Reusable research platforms make it possible to conduct these experiments repeatedly, allowing researchers to refine their methods and achieve more accurate results over time. Another key advantage of reusable space-based research platforms is their ability to support long-term studies. Traditional space missions often have limited timeframes, restricting the scope of research. However, reusable platforms can remain in orbit for extended periods, enabling continuous data collection and analysis. This is particularly valuable for experiments that require long-term observation, such as studying the growth of plants in space or monitoring the effects of cosmic radiation on living organisms. By providing a stable and reusable environment for research, these platforms are helping scientists uncover answers to some of the most pressing questions in science and technology. The potential applications of reusable research platforms extend far beyond Earth as well. As we prepare for future missions to the Moon, Mars, and beyond, these platforms could serve as essential hubs for scientific exploration. Imagine a reusable laboratory on the lunar surface, where astronauts and robotic systems can conduct experiments to support sustainable living and resource utilization. Or consider a fleet of reusable research platforms orbiting Mars, enabling scientists to study the planet's atmosphere, geology, and potential for life in unprecedented detail. The possibilities are truly limitless. In addition to advancing scientific knowledge, reusable space-based research platforms also play a crucial role in inspiring the next generation of explorers and innovators. By making space research more accessible and sustainable, these platforms encourage collaboration across disciplines and nations, fostering a global community of scientists and engineers working together to solve humanity's greatest challenges. They remind us that the pursuit of knowledge knows no bounds, and that the discoveries we make in space today will shape the future of our species for generations to come. As we look ahead, the potential of reusable space-based research platforms continues to grow, offering new opportunities for discovery and innovation. From unlocking the secrets of the universe to developing technologies that improve life on Earth, these platforms are paving the way for a brighter, more connected future. Next, we'll explore how reusable space-based energy storage systems are revolutionizing long-duration missions and reducing our reliance on disposable power sources. Now, let's shift our focus to a critical component of sustainable space exploration: reusable space-based energy storage systems. These systems are not just about powering spacecraft, they're about revolutionizing how we think about energy in the harsh environment of space. Imagine a future where missions to the Moon, Mars, and beyond are powered by energy systems that can be reused, repaired, and upgraded, eliminating the need for single-use batteries and reducing the cost and complexity of long-duration missions. One of the biggest challenges in space exploration is ensuring a reliable and continuous power supply. Traditional missions often rely on disposable batteries or solar panels, which have limitations in terms of lifespan and efficiency. Reusable energy storage systems, on the other hand, offer a game-changing solution. These systems can store energy generated from solar panels or other sources and release it as needed, providing a steady and dependable power supply for months or even years. By reusing these systems across multiple missions, we can significantly reduce waste and make space travel more sustainable. The benefits of reusable energy storage extend far beyond cost savings. For long-duration missions, such as those to Mars or deep space, having a reliable power source is absolutely essential. Reusable systems can be designed to withstand the extreme conditions of space, including temperature fluctuations, radiation, and microgravity. They can also be equipped with advanced monitoring and maintenance capabilities, allowing astronauts or robotic systems to repair or upgrade them as needed. This adaptability ensures that missions can continue without interruption, even in the most challenging environments. Another exciting aspect of reusable energy storage is its potential to support larger and more ambitious missions. For example, a reusable energy system could power a habitat on the Moon, providing electricity for life support systems, scientific instruments, and even manufacturing equipment. On Mars, these systems could enable the production of fuel or other resources using local materials, reducing the need to transport everything from Earth. By making energy storage reusable, we open up new possibilities for exploration and resource utilization, paving the way for sustainable colonies on other worlds. Reusable energy storage systems also have implications for Earth. The technologies developed for space-based energy storage could be adapted for use in remote or off-grid locations, providing clean and reliable power to communities that lack access to traditional energy infrastructure. This cross-pollination of ideas between space and Earth highlights the broader impact of reusable technologies, showing how innovations in one field can benefit humanity as a whole. As we look to the future, reusable space-based energy storage systems will play a vital role in enabling the next generation of space exploration. They represent a shift toward sustainability and efficiency, ensuring that we can explore the cosmos without leaving a trail of waste behind. By investing in these technologies today, we're not just powering missions, we're powering the future of humanity's journey into space. Next, we'll dive into the development of reusable space-based navigation systems, which are enhancing precision and reliability for spacecraft and satellites alike. Now, let's navigate our way to another groundbreaking innovation: reusable space-based navigation systems. These systems are transforming how spacecraft and satellites find their way through the vastness of space, offering unprecedented precision and reliability. Imagine a future where missions to distant planets or complex orbital maneuvers are guided by navigation tools that can be reused, upgraded, and adapted for multiple purposes. This isn't just about getting from point A to point B. It's about redefining how we explore and operate in space. Traditional navigation systems often rely on single-use components or ground-based tracking, which can be limited in accuracy and flexibility. Reusable navigation systems, however, are designed to be robust and adaptable, capable of functioning in the extreme conditions of space while being maintained or upgraded over time. These systems use advanced technologies like artificial intelligence and machine learning to process data in real time, ensuring that spacecraft can adjust their trajectories with pinpoint accuracy. This level of precision is crucial for missions that require complex maneuvers, such as docking with space stations or landing on distant planets. One of the most exciting aspects of reusable navigation systems is their ability to support a wide range of missions. For example, they can guide cargo ships delivering supplies to the International Space Station, or they can help lunar landers touch down safely on the moon's surface. They're also essential for deep space missions, where even the smallest error in navigation could mean missing a target by thousands of miles. By making these systems reusable, we not only reduce costs but also increase the reliability of missions, ensuring that every journey is as efficient and safe as possible. Another key advantage of reusable navigation systems is their potential to enhance satellite operations. Satellites play a critical role in everything from global communications to weather forecasting, but their effectiveness depends on their ability to maintain precise orbits. Reusable navigation systems can help satellites adjust their positions as needed, extending their operational lifespan and reducing the risk of collisions with space debris. This capability is especially important as Earth's orbit becomes increasingly crowded, making accurate navigation more critical than ever. The development of reusable navigation systems also opens up new possibilities for autonomous space exploration. Imagine a fleet of robotic spacecraft exploring distant asteroids or moons, guided by navigation systems that can adapt to unexpected challenges without human intervention. These systems could enable missions that are too risky or complex for human crews, expanding our reach into the solar system and beyond. By investing in reusable navigation technologies, we're not just improving how we navigate space, we're unlocking new frontiers for exploration. As we look ahead, reusable space-based navigation systems will be a cornerstone of sustainable and efficient space travel. They represent a shift toward smarter, more adaptable technologies that can meet the demands of an increasingly ambitious space program. Whether it's guiding a spacecraft to Mars or ensuring a satellite stays on course, these systems are paving the way for a future where precision and reliability are the norm. Next, we'll explore the potential of reusable space-based medical facilities, which are set to revolutionize how we care for astronauts during long-duration missions. Now, let's shift our focus to a critical aspect of long-duration space missions: reusable space-based medical facilities. As humanity sets its sights on exploring deeper into the solar system, ensuring the health and well-being of astronauts becomes a top priority. These reusable medical facilities are designed to provide comprehensive care in the harsh environment of space, offering everything from emergency treatments to routine health monitoring, all while being adaptable for multiple missions. Traditional medical systems in space have often been limited by their single-use nature, requiring new equipment and supplies for each mission. This approach not only increases costs but also limits the scope of medical care that can be provided. Reusable medical facilities, on the other hand, are built to last, with modular components that can be repaired, upgraded, or replaced as needed. This flexibility ensures that astronauts have access to state-of-the-art medical care, no matter how far they are from Earth. One of the most significant advantages of reusable medical facilities is their ability to handle a wide range of health issues. From treating minor injuries to managing chronic conditions, these facilities are equipped with advanced diagnostic tools, surgical equipment, and even telemedicine capabilities. This means that astronauts can receive expert guidance from medical professionals on Earth, even when they're millions of miles away. For example, during a mission to Mars, a reusable medical facility could perform real-time diagnostics and provide life-saving treatments without the need for immediate return to Earth. Another key feature of these facilities is their focus on preventive care. Long-duration missions expose astronauts to unique health risks, such as prolonged exposure to microgravity, radiation, and psychological stress. Reusable medical facilities are designed to monitor these risks continuously, using wearable technology and advanced sensors to track vital signs and detect potential health issues before they become serious. This proactive approach not only improves the safety of astronauts but also enhances their overall performance during missions. The reusability of these facilities also plays a crucial role in sustainability. By designing medical systems that can be used across multiple missions, we reduce the need to launch new equipment with every expedition. This not only cuts down on costs but also minimizes the amount of waste generated in space, contributing to a more sustainable approach to space exploration. Additionally, reusable medical facilities can be upgraded with the latest technologies, ensuring that they remain at the forefront of space medicine. Looking ahead, reusable space-based medical facilities will be essential for supporting ambitious missions to the Moon, Mars, and beyond. They represent a shift toward more resilient and adaptable healthcare systems that can meet the unique challenges of space travel. Whether it's performing emergency surgery on a lunar base or managing the health of a crew on a multi-year journey to Mars, these facilities are paving the way for a future where astronauts can explore the cosmos with confidence. Next, we'll delve into the fascinating world of reusable space-based agriculture systems, which could revolutionize how we grow food in space and sustain future colonies. Now, let's turn our attention to another groundbreaking innovation that could redefine life beyond Earth: reusable space-based agriculture systems. As we dream of establishing colonies on the Moon, Mars, or even distant planets, one of the most pressing challenges is ensuring a sustainable food supply. Reusable agriculture systems are designed to tackle this challenge head-on, offering a way to grow fresh, nutritious food in the harsh environment of space while minimizing waste and maximizing efficiency. Traditional methods of supplying food for space missions have relied heavily on pre-packaged meals, which are limited in variety, shelf life, and nutritional value. While these have worked for short-term missions, they're simply not feasible for long-duration expeditions or permanent settlements. Reusable agriculture systems, however, provide a game-changing solution. These systems are built to operate in microgravity or low-gravity environments, using advanced technologies to cultivate crops efficiently and sustainably. One of the key features of these systems is their modular design, which allows them to be reused across multiple missions. Instead of launching new equipment for every expedition, these systems can be repaired, upgraded, or reconfigured as needed. This not only reduces costs but also ensures that future space colonies have a reliable and continuous source of fresh food. Imagine a lunar greenhouse where crops like lettuce, tomatoes, and wheat are grown in rotating cycles, providing astronauts with a steady supply of fresh produce. Another advantage of reusable agriculture systems is their ability to recycle resources. In space, every drop of water and every ounce of nutrients is precious. These systems are designed to use closed-loop processes, where water is reclaimed from plant transpiration and waste is converted into fertilizer. This creates a self-sustaining ecosystem that minimizes the need for resupply missions from Earth. For example, a Mars colony could use these systems to grow food year-round, even in the planet's thin atmosphere and extreme temperatures. The technology behind these systems is equally impressive. From LED lighting optimized for plant growth to automated monitoring systems that adjust temperature, humidity, and nutrient levels, reusable agriculture systems are at the cutting edge of space innovation. Some designs even incorporate hydroponics or aeroponics, where plants grow without soil, using nutrient-rich water or mist instead. These methods are not only efficient but also lightweight, making them ideal for space missions where every kilogram counts. Beyond their practical benefits, reusable agriculture systems also have a profound psychological impact. For astronauts on long missions, the ability to grow and harvest their own food can provide a sense of normalcy and connection to Earth. Studies have shown that tending to plants can reduce stress and improve mental well-being, which is crucial for maintaining crew morale during extended missions. In a way, these systems do more than just feed the body. They nourish the mind and spirit as well. As we look to the future, reusable space-based agriculture systems will play a vital role in enabling sustainable space exploration. They represent a shift from merely surviving in space to thriving in it, creating the foundation for self-sufficient colonies that can support human life for generations. Whether it's a greenhouse on the Moon or a farm on Mars, these systems are paving the way for a future where space is not just a destination but a home. Next, we'll explore the final piece of the puzzle: reusable space-based waste management systems, which are essential for maintaining the cleanliness and sustainability of future space habitats. Now, let's dive into a critical yet often overlooked aspect of space exploration: reusable space-based waste management systems. As we venture further into the cosmos, the challenge of managing waste in space becomes increasingly important. Unlike on Earth, where waste can be disposed of or recycled with relative ease, space presents a unique set of obstacles. Without proper systems in place, waste can accumulate quickly, posing risks to both the health of astronauts and the functionality of spacecraft. Reusable waste management systems are designed to address these challenges, ensuring that future missions remain clean, efficient, and sustainable. One of the biggest hurdles in space is the lack of gravity, which makes traditional waste disposal methods ineffective. In microgravity environments, waste doesn't simply fall into a bin. It can float around, creating hazards for both equipment and crew. Reusable waste management systems tackle this issue by using advanced containment and processing technologies. For example, some systems employ compactors that compress waste into manageable blocks, reducing its volume and making it easier to store or transport. Others use vacuum systems to collect and contain waste, preventing it from drifting into sensitive areas of the spacecraft. But waste management in space isn't just about containment, it's also about recycling and reuse. Reusable systems are designed to extract valuable resources from waste, turning what would otherwise be a problem into a solution. For instance, organic waste can be processed into fertilizer for space-based agriculture systems, creating a closed-loop cycle that supports food production. Similarly, water can be reclaimed from waste through advanced filtration and purification systems, ensuring that every drop is put to good use. This not only reduces the need for resupply missions, but also minimizes the environmental impact of space exploration. Another key feature of these systems is their modularity and adaptability. Reusable waste management systems are built to be repaired, upgraded, or reconfigured as mission requirements change. This flexibility is crucial for long-duration missions, where the ability to adapt to new challenges can mean the difference between success and failure. Imagine a Mars colony where waste is continuously processed and repurposed, creating a self-sustaining ecosystem that supports both human life and mission objectives. The technology behind these systems is nothing short of revolutionary. From compact, energy-efficient incinerators that safely burn waste to microbial reactors that break down organic matter, reusable waste management systems are pushing the boundaries of what's possible in space. Some designs even incorporate artificial intelligence to optimize waste processing, ensuring that resources are used as efficiently as possible. These innovations not only improve the sustainability of space missions, but also pave the way for more ambitious exploration efforts. Beyond their practical benefits, reusable waste management systems also play a crucial role in maintaining crew morale. Living in a clean, organized environment is essential for the mental well-being of astronauts, especially during long missions. By effectively managing waste, these systems help create a sense of normalcy and comfort, making life in space more bearable. In a way, they do more than just handle trash. They contribute to the overall success and sustainability of space exploration. As we look to the future, reusable space-based waste management systems will be indispensable for ensuring the long-term viability of space habitats. They represent a critical step toward creating self-sufficient colonies that can support human life for generations to come. Whether it's a lunar base or a Martian settlement, these systems will help us turn waste into opportunity, ensuring that space remains a clean and sustainable frontier. With that, we've explored all 25 reusable spacecraft technologies transforming space travel. From reusable rocket boosters to waste management systems, these innovations are reshaping the way we explore the cosmos. But what does the future hold for these technologies? Stay tuned as we delve into the emerging trends and challenges that will shape the next era of space exploration. Now, let's turn our attention to the future of reusable spacecraft technologies, where innovation is accelerating at an unprecedented pace. One of the most exciting trends on the horizon is the integration of artificial intelligence into spacecraft maintenance. Imagine a spacecraft that can diagnose its own issues, predict potential failures, and even perform repairs autonomously. This isn't science fiction, it's the direction we're heading. Artificial intelligence systems are being developed to monitor every aspect of a spacecraft's health, from engine performance to structural integrity. By analyzing vast amounts of data in real time, these systems can identify problems before they become critical, ensuring that missions stay on track and reducing the need for costly interventions. Another groundbreaking innovation is the development of self-repairing materials. Picture a spacecraft hull that can heal itself after being struck by micrometeoroids or experiencing wear and tear. Researchers are working on materials embedded with microscopic capsules that release healing agents when damaged, effectively sealing cracks and restoring structural integrity. This technology could dramatically extend the lifespan of spacecraft, making long-duration missions to distant planets or even interstellar travel more feasible. Self-repairing materials not only enhance durability but also reduce the need for frequent maintenance, saving time and resources. Energy efficiency is also a major focus for the future of reusable spacecraft. Advances in propulsion systems such as ion drives and solar sails are paving the way for more sustainable and cost-effective space travel. These technologies rely on renewable energy sources, reducing the dependency on traditional fuel and minimizing the environmental impact of space exploration. Additionally, reusable energy storage systems like advanced batteries and fuel cells are being designed to support longer missions without the need for resupply. These innovations are crucial for enabling humanity's expansion into the solar system and beyond. The concept of in-orbit manufacturing is another game changer. Instead of launching fully assembled spacecraft from Earth, future missions could involve sending raw materials into orbit and constructing components in space. This approach not only reduces launch costs but also allows for the creation of larger, more complex structures that wouldn't be possible to launch in one piece. Reusable manufacturing platforms in orbit could revolutionize how we build and maintain spacecraft, opening up new possibilities for exploration and habitation. Collaboration between public and private sectors is also shaping the future of reusable spacecraft technologies. Companies like SpaceX, Blue Origin, and others are working alongside space agencies to push the boundaries of what's possible. This partnership is driving rapid advancements from reusable rockets to innovative life support systems and fostering a competitive environment that accelerates progress. As these technologies mature, they'll become more accessible, paving the way for a new era of space exploration that includes not just governments and corporations, but also private individuals and smaller organizations. Looking ahead, the future of reusable spacecraft technologies is filled with promise. From artificial intelligence and self-repairing materials to sustainable energy solutions and in-orbit manufacturing, these innovations are transforming how we think about space travel. They're not just making missions more efficient and cost-effective, they're enabling humanity to dream bigger and reach further than ever before. As we continue to push the boundaries of what's possible, one thing is clear: the future of space exploration is reusable, sustainable, and full of endless possibilities. While the future of reusable spacecraft technologies is undeniably exciting, it's important to acknowledge the challenges and limitations that come with these groundbreaking innovations. One of the most significant hurdles is the technical complexity involved in designing and building reusable systems. Creating spacecraft that can withstand the extreme conditions of space, such as intense heat during re-entry, radiation exposure, and micrometeoroid impacts requires cutting-edge materials and engineering. Ensuring that these systems can be reused multiple times without compromising safety or performance adds another layer of difficulty. For example, reusable heat shields must endure extreme temperatures repeatedly, and even minor wear and tear can lead to catastrophic failures if not addressed properly. Regulatory issues also pose a considerable challenge. Space exploration is governed by a complex web of international agreements and national regulations, which can slow down the development and deployment of new technologies. For instance, launching reusable spacecraft often requires approvals from multiple agencies, and the lack of standardized global regulations can create bureaucratic bottlenecks. Additionally, concerns about space debris and the environmental impact of increased space activity have led to stricter oversight, which, while necessary, can delay progress. Balancing innovation with safety and sustainability is a delicate act that requires collaboration between governments, private companies, and international organizations. Economic considerations are another critical factor. While reusable technologies promise to reduce costs in the long run, the initial investment required to develop and test these systems is substantial. Companies and space agencies must allocate significant resources to research, development, and testing, often with no guarantee of immediate returns. For smaller organizations or startups, this financial burden can be prohibitive, limiting their ability to compete with larger players. Moreover, the economic viability of reusable spacecraft depends on achieving a high launch frequency to offset development costs, which isn't always feasible, especially in the early stages of adoption. Another challenge lies in public perception and acceptance. Reusable spacecraft technologies are still relatively new, and convincing stakeholders, whether they're investors, policymakers, or the general public, of their reliability and safety can be difficult. High-profile failures, such as rocket explosions or mission delays, can erode confidence and slow down progress. Building trust in these technologies requires not only technical success, but also transparent communication and education about their benefits and limitations. Despite these challenges, the potential rewards of reusable spacecraft technologies are too significant to ignore. Overcoming these obstacles will require continued innovation, collaboration, and a shared commitment to advancing space exploration. As we navigate these hurdles, we're not just building better spacecraft, we're laying the foundation for a future where space travel is more sustainable, accessible, and transformative than ever before. Now, let's take a moment to reflect on the profound impact reusable spacecraft technologies are having on the future of space exploration. These innovations are not just incremental improvements, they are reshaping the very foundation of how we approach space travel. By making spacecraft reusable, we're addressing some of the biggest barriers to exploration: cost, sustainability, and accessibility. First, let's talk about sustainability. Traditional space missions often rely on single-use components, which generate significant amounts of space debris and waste. Reusable technologies, on the other hand, are designed to minimize this impact. For instance, reusable rocket boosters and heat shields can be used multiple times, reducing the need to manufacture and launch new components for every mission. This not only cuts down on waste, but also helps preserve the space environment for future missions. Imagine a future where space travel leaves a lighter footprint, allowing us to explore without compromising the integrity of our cosmic neighborhood. Affordability is another game changer. Historically, space exploration has been prohibitively expensive, with launch costs running into the hundreds of millions of dollars. Reusable technologies are slashing these costs dramatically. Take SpaceX's Falcon 9, for example. By reusing its first-stage boosters, the company has reduced launch costs by a significant margin, making space more accessible to a wider range of organizations and even private individuals. This cost reduction is paving the way for more frequent missions, enabling scientific research, commercial ventures, and even space tourism to flourish. Accessibility is perhaps the most exciting aspect of this transformation. As reusable technologies become more widespread, space is no longer the exclusive domain of government agencies and a handful of large corporations. Smaller companies, research institutions, and even startups are now able to participate in space exploration. This democratization of space travel is fostering innovation and collaboration on an unprecedented scale. Imagine a world where students, scientists, and entrepreneurs from all corners of the globe can contribute to humanity's journey into the cosmos. But the impact goes beyond economics and logistics. Reusable technologies are also inspiring a new generation of explorers. By making space travel more attainable, these innovations are reigniting public interest and enthusiasm for space exploration. They're showing us that the stars are not as far out of reach as we once thought. This renewed sense of possibility is driving investment, research, and creativity, setting the stage for breakthroughs we can only begin to imagine. In essence, reusable spacecraft technologies are not just tools, they are catalysts for a new era of space exploration. They're making space travel more sustainable, affordable, and accessible, while inspiring humanity to dream bigger and reach further. As we continue to refine and expand these technologies, we're not just exploring space, we're building a future where the cosmos is within everyone's grasp. And that, truly, is a transformation worth celebrating. As we wrap up our journey through the 25 groundbreaking reusable spacecraft technologies, it's clear that we're standing at the threshold of a new era in space exploration. From reusable rocket boosters and heat shields to space-based solar power stations and interplanetary transport systems, these innovations are not just reshaping how we travel through space, they're redefining what's possible. Each technology we've explored today represents a step toward a future where space travel is more sustainable, affordable, and accessible than ever before. Think about it, reusable technologies are turning what was once science fiction into reality. They're enabling us to dream bigger, reach further, and explore deeper into the cosmos. Whether it's the potential for lunar bases, missions to Mars, or even the possibility of space tourism, these advancements are opening doors that were once firmly shut. They're not just tools for exploration, they're the building blocks of a future where humanity becomes a multi-planetary species, but the impact goes beyond the technical. These technologies are inspiring a new generation of dreamers, innovators, and explorers. They're showing us that the stars are not out of reach and that the universe is a place of endless possibilities. By making space travel more attainable, we're fostering a culture of curiosity, collaboration, and discovery that will drive humanity forward for decades to come. So, as we conclude, I want to leave you with this thought. The future of space exploration is not just about rockets and satellites, it's about people. It's about the scientists, engineers, and visionaries who are pushing the boundaries of what's possible. And it's about you, the dreamers who imagine what could be. Together, we're building a future where the cosmos is within everyone's grasp. If you're as excited about this future as I am, don't forget to hit that subscribe button and ring the notification bell. There's so much more to explore, and I can't wait to take you on this journey with me. Until next time, keep dreaming, keep exploring, and remember, the stars are